Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Paper 2 Standard Level Prediction question. It is not 100% guaranteed this question would be in the exam, but you can think that this as a mock exam to check whether you are ready for the exam or to check what kind of topic that you're still struggling with, so you can go back and then do some revision. If you find this video is helpful, please don't forget to subscribe and let your other friends know about my channel to support me. And let's get started. A solution of calcium chlorate is prepared in 150 centimeter cube of water. The resulting solution has a concentration of 0.1142 molar. Determine the number of moles and the mass of calcium chlorate present in the solution. So we can calculate first the mole, which is C times V. So 0.1142 times 0.15, that would be 0.01713 mole. And to find the mass, it's mole times mR, which is 0.01713 times 206.98 molar mass of this CaClO3 2. Then you will get 3.546 gram. The calcium chlorate solution made above is then mixed with 200 centimeter cube of 0.07500 molar sodium phosphate, producing a precipitate of calcium phosphate. Write the net ionic equation for this reaction, including state symbol. So that would be only Ca3 plus PO4 3 minus produce CaPO4 2, which is solid. This one aqueous and this one aqueous. So this should be 2 and this should be 3. So what will happen with the another ion like Na and like Na? So the products of the double replacement reaction for Na would be NaClO3, but it does not participate in producing Ca should be 3 here, Ca3PO42 or calcium phosphate. So that's why we don't write it here. Determine the limiting reactant in this reaction, showing your work. So there is a reaction between calcium chlorate with sodium phosphate, producing calcium phosphate and sodium chlorate. So the reaction or the equation would be CaClO3 2, which is calcium chlorate, will react with sodium phosphate, producing calcium phosphate and sodium chlorate. So this should be 3 and this should be 3 as well. So as we already did the calculation before, the mole of calcium chlorate, it's 0.01713. So we can calculate also the mole of sodium phosphate, which is 1/3 times 0.0713. So I would just write the answer here, which is 0.0086. To determine which one is the limiting reactant, you need to be careful that 0.0086 is for 1 molecule of sodium phosphate, but 0.01713 is for 3 molecules of calcium chlorate. Therefore, for 1 mole of calcium chlorate is 0.0075, which is smaller. Therefore, the limiting reactant is calcium chlorate. if 1.535 gram of calcium phosphate is recovered, determine the percentage yield in this reaction. So we need to find the theoretical yield of calcium phosphate is N times Mr. As we already know, this one is the limiting reactant. So to find the mole here, we need to refer to the limiting reactant, which is 1/3 times 0.01713 times molecular mass of calcium phosphate, which is 310.18. That would be 1.77 gram. This is for the theoretical yield. So percentage yield will be 1.535 divided by 1.77 times 100. That would be 86.87%. Like calcium, magnesium is an element in group 2 of the periodic table. State the full electron configuration of magnesium, which is 12. So 1s2, 2s2, 2p6, and 3s2. Explain how successive ionization energies can prove that magnesium is in group 2 and period 3 of the periodic table. So there will be a large increase in ionization energy 2 between ionization energy 2, second ionization, and third ionization energy, which shows that there are 2 electrons in the outermost shell. It means this magnesium Mg is in group 2, and there are 2 significant increase energy between second and third and 10th and 11th, right? 10 and 11th. So showing it is in period 3, as there are 3 distinct energy level. So there are 3 distinct energy level. It shows it is in the period 3. State an equation for the reaction between magnesium oxide and water and comment on the pH of the resultant solution. So the reaction of magnesium oxide when it reacts with water, it will produce MgOH2, which is base, so the pH would be bigger than 7. By referring to their relative ionization energy strength, compare and explain the metallic behavior of magnesium to calcium and beryllium. Values from the data booklet are not required. Okay, so if it's in a periodic table, that would be Be, Mg, and Ca. So calcium will have the biggest atomic radius, tends to remove electron easier, or tends to lose, I would say lose electron easier. Thus it requires less ionization energy, promoting more metallic behavior. Why? Ca has the biggest atomic radius, because as you go down a group, number of electron increases, number of shell will increase. Of course, the atomic radius will increase as well. Ethanoic acid has a boiling point of 118 degrees Celsius and is soluble in water. The structural formula of ethanoic acid is shown. State the strongest type of intermolecular interaction formed by ethanoic acid. It has OH, so that would be hydrogen bonding. When ethanoic acid dissolves in water, it reacts to form an ethanoate ion. Write an equation showing the resonance in the ethanoate ion. Include in it the structural formulas for the two resonance structure, showing all charges and non-bonding pair of electron. So that would be the equation first. CH3COOH aqueous react with water liquid, producing CH3COO minus aqueous plus H plus aqueous. So CH3COO minus, so this would be and this one, and it will be the same with negative here. Explain how the dissolution of ethanoic acid in water increases the electrical conductivity of the liquid. The electrical conductivity increases as ethanoic acid dissolve, producing ions in solution that can carry current. An electrical current can be conducted if mobile ions are present in the solution. They move between electrodes in response to the applied potential difference. The solution of ethanoic acid increases, so the amount of mobile ion will increase as well. So it will increase the electrical conductivity. Ethanol and ethanoic acid were added to a reaction vessel, and Q was calculated before equilibrium was reached. State the relationship between the values of Q and Kc. Equilibrium was before equilibrium was reached. It means the equilibrium has not reached yet. So the concentration of reactant is still bigger than concentration of product. Therefore, Q it's smaller than Kc. Okay. Use section 13 of the data booklet to calculate the enthalpy change for the forward reaction. So the delta H would be delta H reactant minus delta H product. The reaction is CH3COOH react with ethanoic acid, CH3, so ethanoic acid react with ethanol, CH3, CH2OH will produce ester, CH3, COOC, H2CH3, and H2O. So if you refer to the section 13, so the reactant, so the reactant is the ethanol, so you get negative 874. So for ethanol, that would be negative 1367 minus 2238. Okay, so it should be negative, so negative 2238, then you get negative 3 kilojoule per mole. The condensed structural formulas of two other organic compounds, A and B, are shown. Suggest why the boiling points of A and B are different. A has higher boiling point because it has a straight change, thus it will have stronger London dispersion force, as it allows them to pack more tightly together, as it allows them to pack more tightly together. So the key here, the more the molecule has branches, the less London dispersion force or intermolecular forces the molecule will have. So the straight change will have higher London dispersion force compared to the one that has branch. Explain why A and B are not soluble in water. A and or B cannot form strong hydrogen bonds with water. As you can see, A or B are non-polar molecule, but water is a polar molecule. So like dissolve like. So non-polar cannot dissolve in a polar solvent. Vice versa. So polar also cannot dissolve in non-polar solvent. Compound Z is a colorless liquid with an unpleasant smell. It is found naturally in some plants such as vanilla. The full structural formula of compound Z is shown. State the IUPAC name of compound Z. The IUPAC name, this is carboxylic acid. And we start with 1, 2, 3. So the alkyl will be at C number 2. So the name would be 2-methyl propanoic acid. Okay, state the number of sigma and pi bonds in this compound. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 1 pi bond. So 13 sigma and 1 pi. The pH of aqueous solution of compound Z differs from that of pure water. Explain this observation. Because compound Z contains COOH group that will dissociate and donates H+. So the pH would be slightly decrease or less than 7. Compound Z is produced by reacting compound X with potassium dichromate as shown. Compound Y is an intermediate of the reaction. So this is the oxidation of primary alcohol. So when it is oxidized, will produce aldehyde and then carboxylic acid. So we just copy it down here. CH3, CH, CH3, C, double bond O, and H. The infrared spectrum of one compound in the reaction mixture is shown. This one. Using section 26 of the data booklet, state the compound that produced this spectrum and give 2 reasons for your answer. So around this, which is OH, okay? So OH present OH at 3,200 to 3,600 centimeter to the power -1 because it's OH. Okay, so for alcohol, 3,200 to 3,600. Okay, so it's alcohol, the first one. So it's compound X. So it's compound X. So there is OH at 3,200 to 3,600 centimeter to the power -1, and there is no C double bond O. That's why the compound it's X, because Y and Z, aldehyde obviously no, because there is OH. So carboxylic acid, compound Z, but there is no carbonyl present, so that's why it's compound X. Compound Y can be separated from compound X and Z by fractional distillation of the reaction mixture. Explain how differences in the intermolecular bonding of compound X, Y, and Z allow compound Y to be removed by fractional distillation. Compound Y, it's aldehyde. It's more volatile as it does not contain hydrogen bond. There is no OH. Yeah, the X is alcohol and then Z is carboxylic acid, where the other compounds X and Z have higher boiling point due to containing hydrogen bond. A student adds excess zinc pellets to 100 centimeter cube of 0.1 molar HNO3 in a beaker. The student tracks the reaction's progress by monitoring the mixture's pH in the beaker over time. The data is collected and graphed. Draw a line of on the graph showing how the pH would change if a solid strip of zinc with equal mass was added to the nitric acid rather than zinc pellets. So now we have 2. Zinc pellets and then zinc strips with the equal mass, but only the difference is for the pellet it has a large surface area, so it has a faster rate compared to the solid strip that has small surface area, so the rate will be slower. Therefore the graph will be the graph will be like this. It will end at the same point because the students use the same mass. So this one steeper because it's a zinc pellet, and this one shallower because it's a zinc strip, so the reaction is slower. On the energy profile diagram below, label lines A and B, then state if the reaction is endothermic or exothermic and justify your response. So A will be activation energy, okay, and then this one will be enthalpy change, which is delta H and is negative, so this one will be exothermic as the delta H decreases. If the energy profile diagram above represents the reaction with a catalyst, sketch how the curve will change if the reaction proceeds without catalyst. So the activation energy should be higher, but the delta H will not change, so you should go down here. Okay, so this one EA without catalyst. One of the main components of the aluminum ore bauxite is aluminum oxide. The ore may be converted to useful materials using both chemical and electrochemical process. Aluminum oxide reacts with hot concentrated sodium hydroxide to form sodium tetrahydroxyaluminate. The equation for this reaction is below. State the coefficient A, B, C in this equation. That would be 2 for NaOH, and then 3 for H2O, and then 2 for NaAlOH4. Draw the Lewis structure of the AlOH4 minus. That would be okay. State the OAlO bond angle in the AlOH4 minus. It will be 109.5 degrees because it has 4 domains, so it is tetrahedral and the bond angle is 109.5 degrees. State why aluminum oxide does not act as a Bronsted lauric acid in this reaction. Because when aluminum oxide react with base, we can call aluminum oxide as an acid because it reacts with a strong base. But actually, there is no proton is transfer between Al2O3 and NaOH. This is what we call phosphoric. Al2O3 is amphoteric. It can act as both base and acid, but it's not amphiprotic that is able to donate and accept proton. The apparatus used to convert aluminum oxide to pure aluminum metal is shown. Write a half equation for the reduction of this dissolved aluminum's ion. So aluminum 3+, so for reduction gaining electron, produce Al. So this one should be cryolite for aluminum 3+. Okay, then this one Al liquid. Explain using section 26 of the data booklet why the production of aluminum is an example of electrolysis. Section 26, it's the reactivity series. In the reactivity series, aluminum is higher than carbon. In the reactivity series, so an input energy is required to make the reaction occurs. The standard enthalpies of formation for selected reactants and products are given in the table. These are the Al2O3 with the standard enthalpy and then Al. So the reaction is Al2O3 produce 3 plus 3C produce 4Al plus 3CO2. So Al is known, C is the free element, so there won't be enthalpy of formation. And for CO2, you can check on the data booklet section 12, which is delta HF CO2 is negative 393.5. So now we can calculate enthalpy change of reaction, which is enthalpy formation of product minus reactant. So 3 times negative 393.5 plus 4 times 10 minus 2 times 1456 negative as well, and you will get 1771.5 kilojoule per mole. Okay, that's it for the explanation for the paper 2 standard level predicted question. It is recommended for you to try to do these questions to check whether you are ready for the exam. And if you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. Thank you for watching, and bye.